Welcome to the second Animal Cognition Lecture. I'd like to begin by reviewing some of the key ideas that we discussed last time. We discussed some of the historical background to the field of animal cognition, and I contrasted two very different approaches. We talked about Descartes, for example, who favored a view that there's a discontinuity between the minds of animals and humans. He said that although animals and humans share many mental characteristics, when it comes to the ability to think and reason, there's a radical discontinuity between the two. Animals cannot think and reason, humans can. And we also saw that Darwin disagreed with this, and he argued for mental continuity between humans and animals. He saying that the two differ in a matter of degree, in the degree to which they can reason and the degree to which they can think. And we also said that Darwin needed this kind of mental continuity in order for his theory of natural selection to be true. And the reason for that is because evolution works on existing structures to modify them, to create descent with modification. So new structures emerge from older structures. So there's a lot of stuff that's carried through. And we also said that Darwin discussed a lot of these mental continuities between animals and humans, but that he tended to rely on anecdotes to support his claims for mental continuity. And we also said that this work by Darwin was carried on by Romanes in his book Animal Intelligence, and he collected anecdotes from many people, which are descriptions of animals engaging in some behavior in some particular situation. And we said that a danger with these anecdotes is that they're often very anthropomorphic. They interpret behavior in very human sorts of terms, applying a lot of mental states and motivations that the animals may simply not have. Right? You can't just uncritically assume that animals would be doing things in exactly the same way that we would. So in today's lecture, we're going to begin by discussing the case of Clever Hans, a famous horse, who illustrates some of the dangers of anthropomorphic interpretations, and also illustrates the need to design carefully controlled experiments when we go about examining the mental abilities of other animals. We're also going to discuss a very important principle called Morgan's Canon, which distinguishes between three types of explanations of animal behavior, and it also says that we should only appeal to higher level psychological mechanisms or processes if we can't explain the animal's behavior using lower level psychological processes. We'll also discuss why that principle is justified, as well as some potential problems with it. And we're going to end by discussing Thorndike's contribution to the animal cognition field. He did his work in the United States and launched the whole field of animal cognition here. So let's begin by discussing the case of Clever Hans, which, as I said, is a famous horse. As I said, this story illustrates the dangers of anthropomorphism, which is explaining behavior of animals by using very human types of interpretations of their behavior. Right? So if animals and humans engage in similar behavior, we uncritically assume that the animals are using very similar processes to those that we're using to produce that behavior. So the story of Clever Hans also illustrates the need to design careful experiments to rule out competing explanations of the behavior in question. All right, so a little bit of background here. In the late 19th century Germany, this man named von Osten, that's his last name, he had a horse named Hans, and he trained Hans to answer questions. and Hans would answer the questions by tapping his hoof on the ground. So a lot of the questions that he could answer were mathematical in nature. So he could solve, for example, addition, subtraction, multiplication, division, and even fractions. So what happened is that von Osten would ask him a question like, what's 4 times 2? And Hans would tap out an answer on the ground with his hoof. So he would tap his hoof 8 times on the ground for 4 times 2. Other things that he could do, he could tell time, he could track calendar dates. So for example, if the 8th of the month falls on a Tuesday, what's the date on the following Friday? And Hans would tap out 11 times on the ground. He also taught Hans to spell German words using a numerical code. So each letter would be represented by a certain number, and if he asked them to spell a certain German word, Hans could do that using this code. So based on this performance, von Osten and others assumed that Hans had high-level mental abilities. Right? He had high-level mental abilities, including the ability to do mental arithmetic. So as I said earlier, they assumed that Hans was doing the same thing that we would do under similar situations. Right? If we were asked the question, what is 4 times 2, we would engage in some kind of mental calculation. And they assumed that Hans is doing the same thing. And I just also want to add here that there's no evidence that fraud was involved. Right? Von Osten never charged any money for people. So he took Hans on tour, but he never charged any money. He never made any money on this horse. Moreover, people could not detect any kinds of overt communication between von Osten and Hans. Right? So no evidence that he was at least directly trying to communicate with the horse. And other people could ask Hans questions, and he would also be able to answer accurately. Nonetheless, the abilities that were attributed to Hans were debunked by a German researcher named Oskar Pfungst. So Pfungst was interested in trying to figure out exactly what's going on here. He could not believe that Hans actually had these great mathematical abilities. He said, before we jump to that conclusion, we need to rule out other possibilities. So he said one possibility is that maybe von Osten is unconsciously cueing Hans to provide the right answers. So he said that it's possible that he's unconsciously providing certain visual cues that Hans is picking up on. Right, so he thought to test this, he designed an experiment where he manipulated, right, where the independent variable was, whether or not Hans could see the person asking the question. Right, and when Hans could not see the person asking the question, his performance collapsed, right? So he couldn't answer accurately anymore. So what Pfungst discovered was that people were providing Hans with go signals and stop signals. Go signals would be certain bodily cues that told Hans to start tapping his hoof. So as soon as they asked a question, they would raise their eyebrows and they might lean forward, and then Hans would start tapping out an answer. And as soon as they get to the requisite number of hoofs, then they would provide stop signals, like relaxing their posture and so on, indicating relief, which Hans was able to pick up on and then know to stop tapping. So it's not surprising that Hans is using cues like this instead of something like mental arithmetic, because Hans, being a horse, is a herd animal, and herd animals are very, very sensitive to each other. Right? They pick up on very subtle cues from each other's behavior and use that to determine their own behavior. Okay, so to summarize, Hans was responding to visual cues and not doing mental arithmetic or any of the other intellectual feats that people were attributing to him. But again, this could only be discovered by designing carefully controlled experiments. Right? Only in this way can you rule out different possible interpretations of what's going on. Right? And that's the whole field of animal cognition, is designing carefully controlled experiments to rule out competing explanations of animal behavior. So that's why in this course I'm going to hammer away at experiments, right? You're going to get one experiment after another to test these different claims. Anecdotes cannot be used to rule out alternative explanations of events, of behavior, because they're not controlled, right? They don't impose the right controls in order for you to be able to tease out different potential causes of the behavior. So this brings me to another very important figure in the history of animal cognition, and that's Conway Lloyd Morgan, right? A British scientist working in the 19th and first part of the 20th century. He wrote an important book titled An Introduction to Comparative Psychology, and it's an amazing book and very important because it stressed methodological issues in terms of how to study other minds. And he also was very much aware of the dangers of anthropomorphism. And I would also like to point out that he had probably one of the best beards in the history of psychology. I am definitely envious. So what Morgan says, as far as a preamble to the study of animal cognition, is that we need to keep in mind how difficult it is to know what's going on inside the mind of anything, right? Forget about animals for a minute. It's hard to know what's going on in the minds of people who are different from us, right? Think about how difficult it is to understand people from different cultures. Or think about how difficult it is to understand what's going on inside the mind of a child, right? You think you have a child figured out, and then they do something that tells you you have no idea what's going on inside their mind. Right? So he says, in our midst there are beings so like us and yet so different. The understanding of whose mental processes is difficult and yet most important. I refer to our own children. How unexpected are often the actions of children. And the fact that children's behavior is often unpredictable tells you that you really don't understand very much what's going on inside their mind. So given that it's difficult to understand the minds of children, given that it's difficult to understand the minds of people from different cultures, what makes us think that it's going to be easy to understand the mind of other animals? Right? You can't just assume that an animal mind is simply a scaled down version of a human mind. Right? It could end up being very, very different. So Morgan says that quite often we have a choice of different possible interpretations of animal behavior as to what caused that animal behavior. So this raises the question, how should we decide which mental processes to attribute to an animal, given that you have a choice? Right? And he proposed what's come to be known as Morgan's Canon. And it says, in no case may we interpret an action as the outcome of the exercise of a higher psychical faculty, if it can be interpreted as the outcome of the exercise of one which stands lower in the psychological scale. Okay, so always interpret, when you can, the behavior of animals using the lowest level possible. Now, this obviously raises the question of, well, what do we mean by higher and lower? Right? It's often criticized as being ambiguous. But he does try to make it more specific, and this is something that people who write books on animal cognition, for example, they don't really delve very deeply into Morgan's own work, because he actually does try to distinguish what he means by higher and lower. And since I have read them, I will be making use of this distinction. Right? So he claims that there's three types of faculties that are arranged hierarchically. At the very bottom we have instinct, which are innate automatic motor responses that occur in response to a particular stimulus. Right? So these are innate reflexes. They don't require conscious control during their execution. And Morgan gives the example of baby chicks. Right? When they're born, within a few hours, if you put food in front of them, they'll peck at it and they'll swallow. Right, so he says that pecking and swallowing is an instinct for chicks. At the next level up, we have what's called what Morgan called intelligence. And he says this is a conscious, goal-directed process whereby an animal tries to improve its performance in some activity based on its experience. Right, so the animal has a goal in mind. It's trying to achieve something, and it engages in trial and error learning in order to try to achieve that goal. Right, so intelligence is not a good word to use. I use it because that's the one that he uses. But really what he has in mind here is goal-directed learning. Right, so animals try out different things in order to achieve certain goals, and depending on the consequences, those actions become more or less common. So, for example, he gives the example of those chicks that he had in his house. Right, he presented them with caterpillars, and they figured out that pecking and swallowing at the caterpillars is not very tasty, right? So they didn't like it, so they started to avoid those, and they started to prefer pecking and swallowing at worms, right? Worms taste good for them, caterpillars do not, so they exhibit intelligence when they start to modify their behavior towards a preference for pecking and swallowing at worms. So he says this accuracy is the result of trial and error. What we term the control over our activities is gained in and through the conscious reinforcement of those modes of response which are successful, and the inhibition of those modes of response which are unsuccessful. So we're going to see this idea again and again in this course when we talk about learning, right? Learning behavior being shaped by its consequences. If an animal has positive experiences as a result of engaging in some action with a stimulus, that action will become more common. And if it doesn't like the consequences, that response to the stimulus becomes less common. Reason. This is the highest psychological level according to Morgan. For you to attribute an animal reason, the animal has to understand the nature of the problem that it's trying to solve. Right? It requires that the animal has insight into the problem, which means that the animal has to be able to understand why engaging in a certain action is going to have the desired effect. Right? So it has to have that level of understanding in order for it to be to count as reason. So let's say, for example, that we're talking about a chimpanzee engaging in termite fishing. Right? Chimpanzees will approach a termite nest, and they'll stick a stick inside the nest, and the termites will cling to that stick as the chimpanzee pulls it out. The chimp will remove those termites, and then it'll eat them. Now obviously excess branches need to be removed from the stick before the stick is placed in the mount. But let's say that a chimpanzee picks up a stick and it's full of branches, right? If it looked at the stick and looked at the hole and then removed the branches and then put the stick inside the hole, we would probably consider that to be a pretty insightful behavior, and then more likely to attribute that to reason. Right? If the chimpanzee grabbed a stick with branches and tried to stick it into the ground, and obviously it didn't fit, and then fiddled with it by chance, and then succeeded in it fitting, that would probably look more like trial and error, and be explained by appealing to learning rather than reason. Right. So if she figures this out beforehand, rather than to trial and error, we're more comfortable attributing reason to the animal. So what we're going to see in this course, especially as we go on towards the later part of the course, where we'll be talking about a lot of experiments, a lot of research in animal cognition is precisely trying to determine whether we need to give more deflationary explanations of any given area. Right? So we'll see that a lot of animal cognition researchers claim to have discovered some interesting reasoning ability on the part of an animal, and then other researchers try to design experiments to show that no, it's actually just a clever type of learning. Right? There's some kind of trial and errors involved that the original researchers weren't aware of. So we're going to see this dynamic play out throughout the course. So to illustrate how to apply Morgan's canon, I want to focus on the example of the case of Portia fimbriata, a fascinating spider, a jumping spider that's native to Australia. And in this case, you can see it jumping, and the bee that's sitting on that flower has absolutely no idea the fate that awaits it. But it's going to end up being lunch for that spider. Portia is a fascinating spider. She eats not only insects but other spiders, right? And the way that she eats other spiders is that she invades their webs. But obviously she can't just invade the web of another spider, because she can become prey herself. So Portia is actually cleverer than that, right? So to avoid counterattack by the resident spider, Portia engages in what's called aggressive mimicry. So she pretends to be the prey of different types of snakes. She pretends to be the prey of different types ensnared in the web of the resident spider. Right. So if a resident spider eats a particular type of insect, she pretends to be that type of insect. And and by doing that, it lures the resident spider towards her, thinking that it has trapped an insect of some sort, and then Portia attacks. So what we know about Portia is that she has a repertoire of signals. What she does is that she creates a certain vibration pattern on the web of the resident spider. So she approaches the web, sees what kind of spider it is, and makes the appropriate vibration for the prey that it likes to eat. And a lot of this is instinctive, right? So it has a repertoire that it uses when for a certain set of spiders. So for a bunch of spiders, she knows innately and instinctively what prey they like to eat, and as a result, what kind of vibration pattern to use. But not all strategies of aggressive mimicry are pre-programmed, right? So sometimes she encounters spiders that she doesn't recognize, and therefore doesn't know what kind of prey they eat. So what she does is she uses a trial and error strategy to attack spiders that she isn't familiar with. So how does this trial and error strategy work? What she does is she tries out different combinations of patterns, right, and then waits to see if she gets a reaction from the resident spider. And then so she'll try vibration, she'll wait for a reaction, and then if she gets the reaction that she wants, she keeps repeating that vibration pattern until the resident spider comes. As Jackson and Pollard say, when using trial and error, Portia associates success with a particular signal and remembers to keep using it. And I want to go back here for a second and mention something that's important to understand why this works. Portia has very good eyesight for a spider. Right? Spiders in general don't have very good eyesight, but Portia does. That's why she's able to see what kind of resident spider it is. But the resident spider isn't very good at seeing that it's a spider that's producing the vibrations. So in terms of Morgan's scheme, how do we go about explaining the behavior? Well, we only need to attribute instinct and intelligence, right? The repertoire of the repertoire that she uses for spiders that she's very familiar with is innate, right? She has a built-in set of responses that for certain types of spiders. That's instinct. But she also has a strategy that she uses for new spiders, for spiders that aren't part of her normal ecology. And that's where you have to jump to the level of intelligence, or trial and error learning from our perspective. At no point, however, do we need to attribute to Portia the ability to reason. Right? That is not required, and so we shouldn't attribute it to Portia unless we have further evidence that suggests that she has some kind of insight into the problems that she's solving. Now, an important question to address is, well, why use Morgan's canon? It should only be used, obviously, if we think that it's more likely to be correct, right? Are we more likely to be correct if we use it than if we don't? So in justifying this principle of how to interpret animal minds, Morgan gives the following argument. He says that instinct evolved first, then intelligence, and finally reason. Because things evolved in this way, we would expect all animals to possess instincts, right? We expect instincts to be present throughout the animal kingdom. We expect some of these animals to later on have evolved the ability to learn, right? Intelligence. And only later would some of these acquire the ability to reason. Because of that, because of this evolutionary history and just the overall base rates that are present, right? We expect a lot of animals to have instincts, fewer to have the ability to learn by trial and error, and fewer still to have the ability to reason, simply because of the evolutionary line here. Because of that, it's reasonable to only postulate the higher mechanisms if you can't explain their behavior by using a more common lower level mechanism, right? Mechanisms that are more common are more likely to be present in any given animal. Now, while Morgan attributed to animals instincts and the ability to learn, he wasn't convinced that they were capable of reason, but he was open to the possibility. Right? In his book, he says, "I have expressed my opinion that in the activities of the higher animals, marvelously intelligent as they often are, there is no evidence that the true perception of relationships, which is essential to reason. But this is merely an opinion and not a settled conviction. I shall not be the least ashamed of myself if I change this view before the close of the present year." So he was very much a data-driven guy. Right? He said that you might come up with experimental evidence that would force him to accept the idea that animals are capable of reason. Now, having discussed that, it's also important to mention some possible limitations of Morgan's canon. First of all, when talking about higher and lower, Morgan seems to assume a kind of linear scale, right? The idea of the great chain of being that we talked about last time. And we saw that things are more complicated than that. Nature doesn't form a neat hierarchy, right? Nature is a massively complex system, right? The tree of life is full of different branches that go in different directions. So life is more complicated, and psychological mechanisms are more complicated than Morgan foresaw. So, for example, evolutionary psychology has shown that there is an incredible diversity in psychological mechanisms, even at the same level. Right? So if you talk about just the ability to reason, they say that there isn't a single reasoning mechanism. Right? So, for example, humans don't just possess the faculty of reason. right? They possess a wide variety of reasoning mechanisms. And each of these reasoning mechanisms is specially designed for reasoning about certain domains. We have, for example, mechanisms for reasoning about other minds. So when we interpret other people's beliefs and desires and knowledge, right, we have one set of reasoning mechanisms, and we don't use those mechanisms for reasoning about other things. We also have mechanisms for reasoning about other objects. We have mechanisms for reasoning about social contracts, right? A social contract is when people engage in cooperation for mutual benefit. Each contributes something, they exchange something in return for something else, and that requires a whole other set of processes, right, that evolutionary psychologists talk about. So you could go on and on and on, and if you take evolutionary psychology, you'd see that there are possibly hundreds of reasoning mechanisms. What's the point? Well, because there's so many, it's possible that animals possess some of these, but not others, right? They may even have some reasoning mechanisms that we don't have, right? And the same is the case with learning, right? There isn't just a single type of learning, right? Learning isn't just one thing. There's lots of different reasoning or learning mechanisms. Animals may have some, they may have both, and they may have none. So, to summarize, there isn't just three psychological mechanisms, right? The situation is much more complex. Our choices are much more complex than just three mechanisms. Right, so the situation is much more complex than Morgan had foresaw. But does that mean that we need to throw out Morgan's canon? And the answer is no, because we can still talk about, even though there's lots of specific mechanisms, we can still talk about three general types of mechanisms. And in general, if you think in terms of types, it's still true that we should attribute animals the lowest type that we need in order to explain their behavior. Right? We should favor interpretations that appeal to types that are generally more common than ones that are more rare. Right? So learning mechanisms in general are more likely to be present than reasoning mechanisms, because reasoning mechanisms evolve later on. Okay, so we can still uphold Morgan's canon, even if we admit that when you're talking about specific mechanisms within each of these levels, the situation is much more complex. All right, now I would like to end this lecture by discussing another important figure in the history of animal cognition, and that's Edward Thorndike. His life and work overlapped to some extent with Morgan, but Morgan was set in Europe while Thorndike set up the study of animal cognition in America. Right, so he's an American psychologist who spent much of his time working at Columbia University in New York. And his work on animals started in graduate school. And as we'll see, one of the things that Thorndike contributed was an emphasis on carefully designed experiments. And he did a lot of his experiments on cats. And he was very much interested and inspired by the anecdotes contained in Romaine's book, Animal Intelligence. Not that he agreed with them by any stretch of the imagination, but he used a lot of them as a starting point for a lot of his own work. So here's an example from Romaine. So according to Romaine's, cats learn by imitation how to open doors. And this is what he says. Walking up to the door with a most matter-of-fact, coarse kind of air, she used to spring at the half-loop handle just below the thumb latch. Holding on to the bottom of this half-hoop with one forepaw, she then raised the other to the thumb piece, and while depressing the latter, finally with her hind legs, scratched and pushed the doorposts so as to open the door. Of course, in all such cases, the cats must have previously observed that the doors are opened by persons placing their hands upon the handles. And, having observed this, the animals forthwith act by what may be strictly termed rational imitation. First, the animal must have observed that the door is opened by the hand grasping the handle and moving the latch. Next, she must reason by the logic of feelings, whatever that is. If a hand can do it, why not a paw? If a hand can do it, why not a paw? I think that would make a great bumper sticker. So Thorndike, reading anecdotes like this, wondered whether cats really learn this way. Right? Can they reason? Can they engage in imitation? Or is there something else going on? So he used orange crates. Being a poor graduate student, he designed these puzzle boxes to see how it is that cats solve problems. Right. So he would place cats in these boxes, and then he would see how long it takes them to figure out how to get out. So each box had a latch inside, and he put the cat in the box and recorded how long it took the cat to get out of the box. And if some kind of insightful reasoning process was involved, you'd expect the transition to go to be abrupt, from not being able to solve the problem of how to get out to all of a sudden being able to solve it. Right? And once they figure it out, they should always do it very, very quickly. Instead, what Thorndike noticed was that the cats just move around in an apparently random fashion until they hit the latch by accident. And the time to solution gradually became faster. It wasn't all of a sudden. Right? So cats got faster with each trial, and eventually they were able to open the latch as soon as they were put in the box. But it took a long time to get there. So according to Thorndike, this shows that cats lack insight, at least in this case, and they seem to engage in trial and error learning, or to use Morgan's sense, intelligence. So based on the performance of cats in his puzzle boxes, Thorndike formulated what's called the law of effect. And this law says that responses to a situation that are followed by satisfaction are strengthened, and responses that are followed by discomfort are weakened. Right? So the idea is that animals emit responses randomly, and depending on the consequences, whether they're favorable or unfavorable, those responses become more or less common. And this should ring a bell because it ultimately was used by behaviorists like Skinner to create the idea of operant conditioning. All right, so I want to end this discussion by clarifying 2 points here, right? What are Thorndike's contributions? First, he discovered an important law of learning, which became the cornerstone of behaviorism, right? The law of effect became operant conditioning. And a lot of animal behavior can be explained by appealing to the law of effect, as we'll see. But methodologically, he also made a huge contribution. Right? He ushered in, at least in America, the rigorous experimental approach to the study of animals. Right? He brought animals, he conducted his research in a lab under tightly controlled conditions.